Here we have a 4090 Founders Edition video card that came in for repair. The card looks something like this. I already have it plugged in. I was testing the card and I thought, let me make a video on it. Customer mailed over the card along with the original housing and also a water block. If we read what the customer wrote, it worked fine with air cooling and I bought a water block to make it water cooled. I installed it and nothing will come on the screen. I also drained it and tried it in another machine and it won't come up during boot. There was never any liquid damage to it at all. When I was converting it, the water block had some spacers on it that I had to remove for it to sandwich the board correctly. Yet another case of, if it's working, let's break it. I always tell viewers and customers, if it's not broken, use it, enjoy it. If it's not broken, do not fix it. People take a good working card, a good working device, and they ruin it. For what? For having the advantage of 5 degrees cooler, 10 degrees cooler, 7 degrees cooler. It doesn't make sense. Unless you know what you are doing, then by all means. Now, I already have the card plugged in, PCIe. I have the cable. And I want to plug the HDMI cable or display cable. And we're going to power the device on. Are we going to hear 6 beeps? Or are we going to see an image? 6 beeps. Right off the bat, we got 6 beeps. While the board is beeping, maybe we can take some measurements quick. I mean, it looks like it's a case of possibly damaged components on the board. Anytime somebody takes off the housing on a video card and he replaces it with a water-cooled housing, most of the times they knock components off the board. Most of the times. Those components are microscopic and you can easily knock off the components. If we measure 12 volts, we do not want to measure voltage in diode mode. So let's go to voltage mode. Measure 12 volts. We should have 12 volts. We do. And the second one, we have 12 volts. Let me shut off the card. And back on again. I want to measure core quick before it goes off. We have 0.6 and 0. That's not good. Core is low. We have memory. Yeah. Let me unplug. We're going to do a quick visual inspection on the board, and I can almost guarantee you that we're going to have something knocked off the board because a card does not just fail for no reason. The card was working fine before, as the customer indicated. As soon as he changed to water cooling, it stopped working. Why? Why would it stop working? If the card has no liquid damage, it has to be that a component was affected, a component was knocked off. Just common sense. We're going to start from the far here, far end, far right, and just take it one step at a time. We're going to visually inspect the whole board. If we're going to have ripped components, usually it's on the bottom, next to the PCIe connector. But we're going to go over the whole board. And thermal pads on this card are all over the place. Same issue with liquid metal. People want to replace thermal paste with liquid metal, and they end up shorting the board, getting liquid metal under the BGA chips. And what's that line? I do not know what that is. I did not touch the board yet. But the board came open like this. It came disassembled. Customer mailed over the water block and the fan housing. So it looks like maybe something slipped with the customer that caused that line. We need to look carefully in this area. Look at this. Look at this. Look at this. I knew it. I knew it. We have two knocked resistors, and those resistors can break the circuit. This component is completely out. Let me fix my hot air station because I was working on a Benz key fob, which I also did a video on, and I had airspeed on low and I had the temperature on low. Those Benz key fobs are 2 layers. They do not like a lot of heat. You can see how much heat it takes to solder or desolder just one tiny microscopic component, because that board is thick, a lot of layers. One user in the comments wrote, how come you do not use an oscilloscope? I never seen you use an oscilloscope. Why in the world would I use an oscilloscope if I do not need it? I do have one in the shop here. And it's a device, it's a testing tool that's never used, ever. Unless you are dealing with sensitive audio devices or you deal a lot with checking signals, you will never use an oscilloscope. People think if they do not use a spectrum analyzer or they do not use an oscilloscope, it's not really a repair. These are the type of people that like to make their lives a lot harder. Why take a straight path when you can take a crooked path? That's how they think. If I do not take a crooked path and suffer, then I did not really make my destination. Some people are like that. When you have an easy path and you have a hard path, you take the easy one. Always. If you are in a war fighting, and you say to yourself, how come we never use swords? Why in the world would you want to use a sword? Well, it's not really a war if there are no swords and horses involved. You're watching too many movies. That's all I can tell you. They used to fight with swords and horses, and wars used to be very difficult. Look at me, I'm using an oscilloscope. Stupid. People who ask those questions are usually either kids or newbies. All right, so maybe we should continue with visual inspection. See if there's anything else wrong with the board. this side of the board looks good, flip the board, start all the way down at the bottom. Maybe I'll go horizontally this time, all the way across. Usually if we're gonna have any knocked components, it will be on bottom of the board, usually. I'm trying not to miss anything, but you're gonna have that one viewer in the comments, oh, you missed it. It looks like you missed two components, and that viewer is looking at those pads right here. You either ignore that viewer, or you delete the comment, or you block that user, something. Because sometimes one comment can confuse the whole community. Look at this, we have another component here. Let's go up a bit. How come those components are crooked? That's how they are from the factory. And I think I went over all the board, front and back. And I'm optimistic. We should have a working board. Plug the cord in. Plug the cable. Now we're gonna plug the display cable. And we're gonna turn the power supply on. Are we gonna hear 6 beeps? We do not have 6 beeps anymore, but I do not see anything on the screen because most likely we need to have the fans and heatsink on the board. I do not see a display, but we did not get 6 beeps. I'm gonna ask Big Boss to install the heatsink and fan, and we'll try again. Those boards, they get hot so fast that they shut off before they display anything on the screen for protection. I'll be back. Okay, I'm back. It's a no-go. We did put the heatsink and fan, and we do have a chirp, but a black screen. Nothing is showing up on the screen. Now here's what I did, and here's what I discovered, so I do not waste your time. You know the capacitor that we soldered back in place? It turns out that the pad under it was weak. You can tell how that pad is missing. First we soldered the 2 resistors, and then we discovered a knocked off component on back of the board. We soldered that component back, but then when the cord did not work, I went over the 2 resistors. They are soldered on properly. I went over this capacitor and I noticed that the cap has a broken pad under it. The broken pad actually connects with the top resistor. Let me show you. I saved you a lot of back and forth and just going straight to the point. If we measure from here to right here, see? From here to right here, see? So we know that the top pad of the capacitor. It connects with the bottom part of the resistor. And that's what we're going to do. We're going to solder that cap back from one side, and then we're going to connect this cap with the top resistor via a solder blob or a wire. It doesn't matter. I mean, I should have known when that capacitor did not want to align in place. I should have known that there's something wrong under that cap. The cap is soldered from one side right now, and what we can do is we can apply either a wire, or we do not need a wire. Those components are too close to each other. What we can do is we can apply a solder blob connecting the capacitor to the resistor. And we'll try again. I'm not going to apply flux. Done. A nice bridge. What if we measure from, what do we get if we measure from here to here? So if you measure from here to here, we have 0.5. That's good. So we know the cap is making a connection with the resistor. And all we have to do is test. And hopefully this time we get an image. One way to find out, right? We're going to plug the cord in. The 12V HPWR connector, which is connecting to 3 12-volt lines. And we're going to have the display cable. I actually removed the display adapter from the HDMI cable so I can test it both ways, and we still did not get an image. So now I'm going to put that display adapter back on. Power on. We should hear a chirp. And we need to see something on the screen. Nothing. Let me take some measurements. So we're going to turn the power supply off, back on, and I'm going to measure V-core quick. Before we had 0.5. Now we have 0.9. Chirp, we still have 0.9. And 0.9 is pretty high. We should be at 0.7 plus. And V-core went off. So right now when I turn on the computer and I measure, we have 0.9 V-core before we had 0.5. Power supply on. We have 0.9. We have 1.8. And let me turn off the power supply and back on. I want to test memory if we have it for a split second, because I do not have the heatsink and fan connected. And we do 1.3 if we measure packs. We have 0.98. Perfect. So we have all voltage rails. So we're going to plug the heatsink and fans. And I'll be back. I did some more measurements on the board, and here's what I found out. I found out that we're not going to be able to repair this cord. If we go down to the 1.8 volt line, we are getting 1.8 volts here. I told you all voltage lines are present. But if we measure 1.8 volt in resistance mode, we have exactly 0 ohms. If I go to continuity, if we measure here, we are reading 1.8 volts here when it's plugged in, but when the cord is not plugged in, I'm reading 0 ohm short. A 0 ohm short on the 1.8 volt line is very likely a dead core. And when we have a dead core on the 4090 or any cord, it's game over. We are done. So all that work for nothing, what can you do? But at least you learned something from this video. We're gonna deem the card a no fix. We'll let the customer know. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe. And we'll do something else in the next video.